We can rearrange basic formulas using the same method that we did for solving linear equations. So taking this formula here, I'm just trying to solve for f. So I'm going to imagine c is just a number, okay? And then we're going to move it around like a number. We're not going to evaluate anything with it, but we're just going to move it around like we did with any other number. So the first thing I'm going to do here is I'm going to actually distribute the 5/9 to unlock those parentheses. There's actually a number of ways you can solve these types of problems, but this is just how I'm going to do it here. Okay, 5 times 32, because this is the same thing as 32 over 1, so we can multiply the numerators. That's going to be 150, 160 over 9. Now to get f by itself, I'm going to add the 160 over 9 first. Both sides of the equal sign again. So we get c plus 160 over 9 equals, those cancel, we get 5/9 f. Now to get rid of 5/9 f, or the 5/9, I can divide by 5 over 9, or I can also multiply by 9 over 5. That's the same thing as dividing by 5/9, multiplied by the reciprocal. This is just a cleaner way of doing it because the 9 cancels the 9, the 5 the 5, and we get f by itself. So I'm going to multiply everything on the right-hand side by 9/5. That just ends up, since multiplication is commutative, I can just multiply 9/5 times 5/9. On the right-hand side, I have to put it in parentheses because everything is being multiplied by 9/5. And that's what the parentheses do. It distributes into everything. And here we have our answer. F equals 9/5 c plus 160 over 9. This is not the simplest form, however. If I distribute the 9/5 in, I can get the simplest form. The c is quite simple. I'm going to write it on this side. 9/5 times c. And you can see, well, 9/5 times 160 over 9, the 9's cancel. And the 5 reduces with the 160 to make it 32. And this is a much nicer form to have it in. I could have actually got this form simpler or easier in the very beginning by, instead of distributing the 5/9, I multiply by 9/5 as the first step. Then I can just add 32 over, and that would have brought me directly to this form, though this is a different way of doing it. Whatever way makes more sense to you, just follow that method. Okay, for this next one, this, by the way, this is just converting Celsius and Fahrenheit. That's what that formula means. This formula here is the area of a trapezoid. You multiply it by h, which is the height of the trapezoid, and a and b are the different legs of a trapezoid, the parallel ones. But all we're going to do here is solve for the height. And we have to use a technique that's important to keep in mind whenever you're working with this. We have two instances of h, and we need to combine them into one instance. And it's quite easy to do this when a and b are numbers, because it's obvious to see what they are. They end up being like terms. When you have variables, it may not be clear what we're doing. All I'm doing is this. I'm just looking at HA. So imagine A is 3 for a moment. And then h times a is just 3h. And h times b, imagine b is 2. So that would be 2h. Well, 3h plus 2h, this is just 5h. But you did that by thinking of it as 3 plus 2h. That's really what we're doing there, is we are combining like terms using this method, and 3 plus 2 is 5. The same idea happens, though, if we change this. I'm going to get rid of this 5h for a moment. Change this to a. Sorry, this was a, and this was b. This just becomes a plus b. And we can't actually change it to any kind of 5h thing because we can't evaluate what a plus b are, but we can leave it as a plus b. And this is nicer because now we only have a single occurrence of h. Really what we're doing here is we're factoring out the h, or undistributing the h. So I'm going to do that first. I took the h out. Of course, h times a plus b is the same thing as a plus b times h. It's multiplication is commutative, so you can flip them around. Okay, now all we have to do is get h by itself, and this can be done in one step. You can use 2 here if you want. You can multiply by 2, and then divide by a plus b, or divide by a plus b and then multiply by 2. But you can also do both of those at the same time. Multiply by 2 over a plus b. Whatever you do to one side, do to the other. I don't need parentheses here. I could write this whole thing in parentheses, but like in the previous problem, we had an addition. That's why I used parentheses. Here we do not have an addition with the a, so we can just drop them. And the 2's cancel, a plus b's cancel, and we're left with h on the right-hand side. A is over 1, so that gives us 2a over a plus b. And I think that's the cleanest form to have it in. Of course, there's lots of different ways you can write that. Okay, give it a try in number 3. All right, we are back to this problem again. Here we have the, different pay scales and everything. We got 1707.75. We're asking, what is our wage increase? Whenever you're solving a word problem using linear equations or really anything, the most important thing is to know what is the thing you're looking for and give that a variable. In this case, we want a wage increase. I don't need specifically the wage increase. I could write it like this, right? 16 plus W, where W would be the wage increase. I'm not going to write it like that because I know I need to take 16 off of whatever wage increase. It's going to be easier to think of it as W being the new wage. And then after we find W, then we can calculate the wage increase. So W is our variable. I named it W because W stands for wage. Always name your variable something that relates to the problem. Then it'll be easier to know what each means in the very end. If we know what W is, then it's quite easy to find each piece. So first off, we have, I'm just going to follow it the way it's written here, 5 overtime hours. Well, the money I make from 5 overtime hours is going to be 5 times the dollar per hour that I get, the wage of that period. Now, it's not just W, of course, because W is our wage that we make. It's going to be time and a half for overtime hours, meaning, oops, let me use black here. Meaning time and a half for overtime hours is 1.5 times the wage. That's how I like to think of it. I like to think of it as, we work 5 hours, but we get more pay for that. So this is really 1.5 times W. The 8 holiday hours, so if we have 8 holiday hours, we make double time for that holiday hours. So it's really 2 times the wage. We make double our pay for that period. And then, of course, we have the 80 regular hours. 80 regular hours is just at the wage. It's not increased at all. And, of course, if we add these 3 together, this should equal our total earned, our gross pay for that period. This is just a linear equation of one variable. All we have to do is combine the like terms, and we're good to go. Well, we can go ahead and multiply 5 and 1.5, that's 7.5 W. 8 and 2 is 16 W. And 80 W. We have like terms on the left side. 103.5 W is what we get when we combine those. And now all we have to do is divide by 103.5. And double checking my math there. We get 16.5 for the new wage. That means our increase is just the difference between 16.5 and $16 per hour. So it's going to be a 50-cent increase. So I think this problem is easier to solve using linear equations because I think it's more natural to assume that you make more money for the overtime and holiday time than it is to think of it as an increase of hour. However, with the increase of hour method I showed you before, that allowed you to solve this without using an equation. So it's kind of up to you which way you think of it. All right, we have a shop selling t-shirts, and it sets the price 42% of the price as profit. That's the way they set the price. Now, if that shirt had a 20% discount and is on sale for $18, how much would the shop profit from the non-sale price? Okay, so we're trying to find what is the original price of the shirt, and then we can find what is the profit that's from that shirt, because 42% of the original price of a shirt is profit for the shop. Let's do price, and then I'm going to use a subscript here. Price original, a subscript of O for original. So the price original is going to be the original price for a shirt. Okay. Now, all we have to do is figure out how do we get the normal amount from the $18. Well, if a shirt is discounted by 20%, that means the original amount, we took off 20% from the original 100%. We took off 20%. That means that $18 is 80% of the original price. This is an important part of solving percentages problems, is that whenever you're looking at a discount or a markup, for instance, a markup would be adding a certain percentage. What you're doing is you're not removing or adding that 20%. You're really changing the original to be a different percentage, or the new price to be a different percentage of the original. It's 80% of the original price. And this 80% is nicer to use when solving for, the original price. So $18 equals 80%, or 0.8 times the original price. And this is just a linear equation with one variable, right? So we can divide by 0.8 to get the original price back. 18 divided by 0.8 is 22.5. And whenever you're doing problems like this, it's always helpful to check your answer, because sometimes you can get lost in the mathematics, what you're thinking about, and do something incorrectly. What I can do is I can take 22.5 and multiply it by 0.2. That gives me 4.5, or $4.50. So if I take off that 20% from the 22.5, which is the whole price, I get 22.5 minus 4.5 is $18, and that is 80% of the original. So my math checks out that this is the correct original price. Now, this isn't the answer, right? The answer was, how much does the shop profit from the non-sale price? This is the non-sale price, or the original price. And it said that 42% of the original price is profit. That means all we have to do is find what is 42% of this amount. Well, that's quite easy. That's just 0.42 times this original price, or 22.5. And that gives us $9.45. Okay, so that's our answer. That's how much profit they make from the original price of the shirt. Now you can ask, you can actually find it from this information. Um, how much do they make profit off of the sale price? Because they do make a profit. They're not going to, you know, sell it for a loss. But it's just going to be less than this 9.45. I encourage you to think about that and do it on your own. For the next one, we have a plot of land that is 53 by 97. And we have a deal of fencing, of 250 feet of fencing. And we want to figure out how much of the land is fenced in. So this is our land here. Whenever you can draw a picture, do so. It tends to help figure out what you're trying to find. This is 53 feet. And this is the 97 feet. That's the whole plot of land. And we're trying to figure out how much of this 250 fences in, how much of the land fences it in. So you can see that it's not going to fence in all of it in, right? 53 plus 97 plus 53 plus 97. The perimeter of this land in total is going to be 300 feet. So we know the 250 is not going to fence in the entire land. So how much does it fence in? First off, we're going to figure out what are the dimensions of the fence and how much or what percentage of the land is fenced in. Well, we don't know how far it goes forward, but according to this information, we know we want to go as far as possible on the top and the bottom. So we know that this distance here between the top fence and the bottom fence is going to be 53, as much of the land as possible. We don't know how far forward it goes. Okay, and with those two things known, we can actually figure out what we need to from this information. First off, we can find the dimensions of the fence by looking at the perimeter of the fenced in area. So doing the perimeter of this is going to be 53 plus x plus 53 again for this side, plus another x. And that is going to equal, we're going to use as much of the fencing as possible, so it's going to be 250 feet. This is a linear equation of one variable, so we can go ahead and solve it by getting the variable by itself. First off, I've got two like term groups to solve. So 53 plus 53 is 106. X plus x is 2x. And now I can subtract 106 giving me 2x equals 144. Yep, divide by 2. And we get 72. So we know that we are pushing forward 72 feet from the back of the property, as much of the front lawn as possible. Now, that's the dimensions of the fence, 53 by 72. How much of the land is fenced in is the same thing as a percentage. So we want to figure out what is the area of the original land and what's the area of the fenced in land. And if you divide those two things, that's how much the percentage of land fenced in, the area percentage. So if we look at the area of the full land, that's going to be, what was the dimensions? 97 by 53. So we take 97 times by 53. And if we divide this number by the area of the fenced in land, which is 72 by 53, that's going to give us our percentage. Actually, we should do it the other way around. My bad. This is the total area, and then you divide it by the portion that's fenced in. So it's always going to be the smaller number divided by the bigger. Okay, now the 53s, of course, cancel in this fraction, and we can go ahead and do this division, and that'll give us 0.7422 and continues, which is approximately 74%. So almost 3/4 of the land is fenced in when we had this situation here. Okay, the next one we have a truck rental agency. Two different plans for renting a truck. One has a lower starting cost of $83 per week, and then a higher per mile cost. The other one is vice versa, higher starting but a lower per mile. So, what are the equations that model each plan? How many miles driven in a week do both plans cost the same? And then, if you need to drive 300 miles, which plan should you actually use? Well, the first question is what equation models each plan? That's where you're looking at plan A being this per week portion is it might be a little confusing. We're only considering a having a truck rented for a single week. We're not considering multiple weeks here, only for a single week. If we had to do that, there'd end up being two different variables, and it's going to be more confusing. We're only going to consider a single week here. So don't worry about the per week portion. Really, the variable, the thing that changes here is the per mile portion. So our variable of choice that we want is going to be M, which is miles driven. Now, with this information, Plan A charges $83 per week, or $83, plus 7 cents per mile. Well, if we drive M miles, that's going to be 7 cents times M. So this is the formula for Plan A. This, of course, is going to be the, I'll say it's the cost for Plan A. Now for Plan B. So the cost for Plan B. This is going to be $99 per week, so $99 plus 4 cents per mile. Okay, that's what the first question asks. The next one says, how many miles driven in a week do both plans cost the same? In other words, when are the two equal? So I don't really have to worry about this CV or CA. Really, we're just trying to make these two things equal. Well, this is just a linear equation in one variable. Get the variables by themselves. So I'm going to subtract the 0.04 m. It doesn't matter which one you subtract. Just subtract either the 7m to this side or the 4m to the other side. Just subtract one of them, because you'll always be able to get the same answer no matter which way you do it. I'm also going to remove, since I have m on this side, I'm going to remove the 83 from it. And that's going to give me 0.03 m equals 99 minus 83. That's going to be 16. Now I can divide by 0.03. And that's going to give us m equals 533.3 repeating. This is the same thing as 533 and a third. And so that's the even point, the break-even point, where both plans are the exact same cost. Okay, now, if you needed to drive 300 miles, which plan is better? So, we have 300 miles. It's less than this break-even cost, so one of them is going to be cheaper than the other. If you're above the 533 and a third, that means the other plan will be cheaper than the first. But really, the question is, which one is cheaper when you're below this 533 changing point? And this you can see if you just kind of look at the two plans and understand how do the changes happen. But you can also just test it. Just plug 300 into both plans. So if we do 83 plus 0.07 times 300 as our miles, and then 99 plus 0.04 times 300 per mile. Now we just calculate this. 83 plus 0.07 times 300. I get $104. The next one is 99 plus 4 times 300. Next one is 111. And so plan A is the cheaper one of the two. And that is clear from the fact that you have a lower starting cost. 83 is lower. However, in the long run, for very long distance trips, the per mile cost is going to be what you always want to follow. So in the long run, plan B is better because it has a lower per mile cost. But if you're doing short trips, then this plan A works out best because it's a lower starting fee. And you know where the break-even point is, when to switch over between the two of them. Okay, give these kind of ideas a try in numbers 4 and 5.